We are going to look at velocity and velocity and speed. Velocity and speed. Okay. Now velocity has direction. Speed has no direction. So velocity is a vector quantity. Speed is a scalar quantity. How you define velocity, how you define speed, we are going to look at different examples to illustrate.
Okay.
Now, actually, I don't know whether they're going to do something like this or not. You see, maybe next year your assignment will be like this. You have to take a video of yourself running about 50 or 100 meters like that with a stationary camera. You don't turn the camera. You take your phone or a camera, take, right? You record your own running 100 meters or 50 meters. Then after that, you're going to use the software. They will provide you, the college will provide you with the software, and the software will interact with your video. And this software, they can actually plot a graph of your displacement versus time. They can also plot the graph of your velocity versus time. And they're going to
Okay.
ask you, how are you going to interpret the race, whether he's accelerating or slowing down, and so on, right? So we're going to provide you with the software like that. Okay, now we start with speed. Okay, now speed is the path length divided by the time elapsed, the time taken. Actually, it means the time taken. Oh, every physical quantity described here, they have their own specific meaning. You must know exactly what they mean. Okay, now path length. What is path length? Okay, you see here, this is the point A, this is the point B. Now, probably when you move from A to B, you move in a straight line, or you move in a crooked line, from left to right, and you move like that, then you reach B. Okay. Now, path length is the actual distance along this blue line. Okay. Path length is the actual distance taken by you. Okay. Now, if you want to talk about the distance or the displacement, then it is the straight black line. They only interested in the initial position and the final position, then they just draw a straight line there. That is the displacement. But you may turn, you may turn around crooked, you stop here, turn there, turn here, then finally arrive at B. Oh, that is not taken into consideration in displacement. They just take one straight line, stretch from A to B, that is your displacement. Okay. Or while actually you may be not taking a straight line, you may be taking a curve like this. Okay. Now, this
Mm-hmm.
curve is called the path line. It is the actual this actually it is the actual length taken by you. It might be longer than the displacement of AB. Any question on this path line
No.
and and displacement? Can you see the difference between path line and displacement?
Yeah.
Yes. Now, even though you may go from straight from A to B, that is also your path line. If you go straight from A to B, then this straight line A to B is your path line. But if you move in a crooked line from A to B, then this crooked line is the path line. But either case,
Okay.
the straight line is your displacement. Okay or not?
Mm-hmm.
Okay. Right. So you know what is path line. Then elapsed time, elapsed time is the time taken. The time taken from A to B. Whether you do a curve, a zigzag, crooked line, we don't care. At the start of A until the end of B, what is that time? That is the time lapse. Okay. Okay. Now the definition: average speed is this one lah. What we are talking earlier. Okay. Average speed is the path length. Okay. Okay. Here, average speed is the Average speed is the path length divided by the time elapsed. So average speed is in meter per second. Okay, the path length is in meter, the time is in second, right? So this is the definition of average speed. And from here, we can also see the SI unit, the SI unit used. The SI unit for
Okay.
the distance, D, time is T. The SI unit for the average velocity is meter per second. Okay, now we look at example 1.2 from your textbook. Example 1.2. You read problem a turtle.
Problem: a turtle and a rabbit engage in a foot race over a distance of 4 kilometers. The rabbit runs 0.5 kilometers and then stops for a 90-minute lap. Upon awakening, he remembers the race and runs twice as fast, finishing the course in a total time of 1 hour 75 minutes. The rabbit wins the race. Calculate the average speed of the rabbit.
Okay,
And what is his average speed before he stops for a nap? Assume no detours or doubling back.
okay. Now, average speed, we don't worry about the question first. You just look at the formula for average speed. Average speed is the path length divided by the time elapsed. Oh, looking at this formula, you refer back to the question and see whether you can draw the information from the question or not. Path length, how much is the path length from the question? How much is the time elapsed from the question? Okay, so I look back. Oh, they have to travel a distance of 4 kilometer. So from the start until the end, 4 kilometers. Okay, so the path length is 4. Time taken. The time taken is, yeah, finishing the course a total time of 1.75. Now this 1.75, the time taken also includes the time that the rabbit is taking a nap. It is counted. So it will actually slow down the average speed, because the time you rest is also taken as the time in the race.
Okay.
Okay, so actually slow down, but that is how we calculate it. So this is the meaning of average speed, right? It's taken into account. So the total time is 1.75. So you take 4 kilometers divided by 1.75, then it will be 2.29 kilometer per hour. Okay, so this example, they actually want us to get used to this formula. Path length is the path length divided by the time taken. The average speed is the
Okay.
path length divided. So we don't care. We see initially how much, where are they, and finally how far it is away. You just take the distance. Whether he's traveling in a crooked line or straight line for the 4 kilometer length, we don't care. Just take. Then another thing is the time taken. Time taken is from the start until the end. How much time is taken? Whether he took a nap, or whether he walked slowly, then finally very fast. We don't care. We just take the total distance. Okay. Oh, so this is the average speed. This is the definition of average speed. Now, for the second part, what was his average speed before he stopped for a nap? You see, the journey can be divided into three parts. Okay, the journey can be
His
divided into three
initial.
parts. The first part is here. Before he take the nap, the rabbit nap, and the time taken is, let's say, uh, T1 T1 hours. Okay, T1
Mhm.
hours. Then rested for 90 minutes. 90 minutes means 1.5 hours from here to here.
Okay.
Okay, initially take time. I don't know how much is the time, right? But I just call it T1. Then the final lap, this one. After he wake up, then run faster than before, twice as fast as before, and the time taken is T2 hours. T2 hours. The total time is 1.75, but with this time here during the double the speed, we don't know what is the time taken. It's called T2 before T1. So we're actually breaking down the whole journey into three parts: before the nap, during the nap, and after the nap. And some of the quantities there we don't know, so we have to represent it using unknown T1 and T2. Okay, right. Next step, how to solve this problem? We try to relate all the unknowns. Okay, first
Okay.
one, the time T1 plus the 1.5 hours plus the T2, the total is 1.75. Is this okay?
Yeah.
Note that all this timer, the unit must be consistent. The unit, now when I form the equation with the equal sign there, the units T1, 1.5, and T2, they must all be in hours.
Hours. Okay.
Must be consistent, then only you can form the equation. You don't think here second, this one minute, then add together equals to hours. It will be wrong. It will be wrong. Okay, right. So I move the 1.5 over, then the T1 plus T2 is 0.25 hours. Okay, or 0.25 hours. This one, hours. Okay, hours. Okay, now we come back to the formula for the average speed. Average speed is the path length divided by the, sorry, where is it? It's over here. Average speed is the path length divided by time. Now, if you want to convert it, okay, where is it? The average speed equals to, no equal sign, equal to the distance divided by time. Right. Now, I want to change it. I want to make the time the subject of the formula, because in the above equation, it is given in time form. So when you change it to time, time equals to distance divided by the speed. So that is how I get this thing over here.
Okay.
That's how we get this thing over here. It actually comes from where? It actually comes from this one. You just make D the subject, T the subject of the formula. So the time is D over V. So this time T1 is D1 over V1. And this time T2 is D2 over
Over
V2.
V2.
Okay, that means it is for the first part of the journey and the final part of the journey. Okay, this both of them, they are time, but time can be written in the form of the distance, the path length divided by the average velocity. So these two, v1 and v2, they are the average velocity for the first and final part of the journey. Okay, but there is something here, runs twice as fast. Runs twice as fast means the final velocity here is 2 times the initial one, the initial speed, sorry. The final average speed, which is v2, is actually 2 times the average speed of the first part of the journey. Is this okay?
Okay.
Okay. Then the first part of the journey is 0.5 kilometer. 0.5 kilometer. So naturally, the second part of the journey is, the final part of journey is 3.5, because we know the total is 4. So if the first one is 0.5, the final one must be 3.5, the
Fine.
distance, the path length. Then divide by the velocity. This is the velocity for the first part of the journey. Second part of the journey, I no longer call it V2. I no longer call it V2.
2
I call
times
it
V1. 2
2V1.
V1.
Is it okay?
Yep.
Okay. Now, the rest is just how to manipulate with the equation. Okay, how to manipulate with the equation. This is 2v1, so I make this into 2v1. How to
You
make
want
it
times
into
2 to
2v?
make it
Yes.
times 2.
So 0.5 times 2 is 1. Now this one times 2, then is 2v1. Now,
Then you plus it together, you get
because the
4.5.
denominator is the same, so it's
Mhm.
still 2v1, but the top you add together is 4.5. Then from here, you can move the 2v over and divide by the 0.25. So you have 9 kilometers per hour. Now, why am I so sure that it is the unit is kilometer per hour? Because here I already make the hour consistent. Then in the final here, when I substitute in the equation, I make sure it is everything is in kilometer. So I'm very sure the final answer is in kilometer per hour. Okay.